Hello again. Uh, I'd like to do this example problem because it's a little bit weird. All right, this is one where you could, in principle, just rearrange things and it works, but we can do Kirchhoff's laws and it tells you something I think a little more interesting about things. So, what we have here is a 10-volt battery on the left, a 5-volt battery on the right. And at the top of the circuit is a parallel thing. And we already kind of know how to deal with parallel things. We would say, well, it's in parallel, so 1 over 20 ohms plus 1 over 5 ohms is 1 over the parallel resistance. And if you solve that, parallel resistance is 4 ohms, right? So you could do that, and then, well, how do I rearrange other stuff? And you might think, well, the voltage across that, this point is 10 volts on the left, and this point over here is at 5 volts because of the batteries. So maybe the current through that is 5 volts, the difference between the two batteries times 5 volts divided by 4 ohms. And so that's 1.25 ohms. So maybe you think, yeah, we could try that. But we're not certain necessarily. It turns out you can do that. But what I want to do is do Kirchhoff's laws with this. So the idea is that what I'm going to do is say that there's a main current that goes this way, and that is I1, and it goes through the 5 volt and the 10 ohm and the 10 volt. And then it splits up here in the parallel bit, and I'm going to say the bottom one is I2 and the top one is I3. All right. And so what that does is I can work through what's going on. I1 splits. So you'd write I1 is I2 plus I3. And then we can do the voltages. And this is what I mean by loops, is we kind of have to identify where the current's going. So the first loop I want to do, I'm going to write it out here in red, is from this point at the bottom. It's going to go like that. And so that'll give me 10 volts. Oh, sorry. We need to go through and do the plus and minuses. So plus, minus, plus, minus. I1 goes plus, minus. And then I2 and I3 go plus, minus, plus, minus. Good? Now you could invert, you could say I3 goes the other way. Maybe it goes in a little loop like this. And I1 plus I2 equals I3. But we're going to stick with it the way this is because it makes sense for it to branch. There's nothing in this little loop to make it go in a circle like that. So anyway, so we have 10 volts. We go that way, so that's positive. And then we're going to fall over everything else. So minus 5 I2. And then I'm just going to go ahead and drop the units since I know it's volts and ohms. It's going to be amps. So 10 minus 5 I2 minus the 5 volts. And then minus 10 I1. That's 0. Okay. Just in frame. Good. Now, in purple, I want to do the other loop because we ignored the 20 ohm resistor here. So we're going to go from this point, and we're going to go like that. So we'll have 10 volts minus 20 I2, I3, sorry, minus 5 minus 10 I1, and that is 0. Excellent. Now, the third loop is going to be this interior loop, and we're going to start at this bottom corner and go around like that. And so we'll have essentially 5I2, and that's going positive to negative, so that's a negative sign. And then we're going to have 20I3 going negative to positive, so that's a positive 20I3. And what you notice is if I take the red equation and I subtract the purple equation from it, I get the black equation. Now, what this bottom equation does is it tells me the ratio of I2 to I3. It tells me how the current splits in that parallel branch. All right, so we could apply this to circuits that don't require Kirchhoff's laws. We can just, it's like, well, how does it split up? Apply Kirchhoff's law to just that little bit of the circuit, and it tells me the ratio. In this case, it's going to be let's try to isolate I2. Right now, let's try to isolate. Yeah, try to isolate I2. So I2 is going to be 4I3. It's kind of what we expect. It's easier for the current to go through the 5 ohm resistor that has I2, so 4 times as much current will go through it. It's just the ratio of those resistors. So that kind of makes sense. Now, where we have up here at the top, I1 equals I2 plus I3, we can carry that down here. And I've run out of room, obviously. But we can carry that down and say I1 equals, well, we can replace I2 with 4I3 plus I3, which is 5I3. So now we can plug everything in and we can solve for I3 in one of the other equations. I've run out of room, so give me a moment. This purple equation, I'm just going to plug in for I1. So I'll have 10 volts minus 20I3 minus 5. So drop the volts here again. So 10 volts minus 20I3 minus 5 volts minus 10 times 5I3 is 0. And we can solve. The 10 and the 5 go together. It's 5. And then we have 20 and 50 minus 70 I3 is 0. I3 is 5 over 70 amps. And now we can solve for I1 at the bottom. Is 5 times 5 over 70 is 25 over 70 amps. And now we can go and solve for I2. Since we know what I3 is, I2 is going to be 20 over 70 amps. Now that we know that, we can go back through the circuit and say, what is the voltage across all these parts? Well, I1 down here is kind of maybe easy. It's V is IR is, or I here is I1 is 25 over 70 amps times 10 ohms. That is 250 over 70 volts, which is not quite 4. We can go up here. V3 is off the board. V3 is I3. Where is I3? This is why you circle your stuff. I3 is 5 over 70. I1 is 25 over 70. I2 is 20 over 70. Right? So V3 is 5 over 70 amps times 20 ohms is 100 over 70 volts. I've lost some space here, so there's the writing. And then finally, this bit is 5 ohms times I2. 5 ohms times 20 over 70 amps is, again, 100 over 70 volts. I realize I've just made this look like I solved the Kennedy assassination. I can make some more videos, but I'm going to go ahead and upload this. And I'm going to once again show you my precious baby, Francis. Let's be honest. I'd much rather just make cat videos. All right. Good night, everybody.